Our project is a real-time health monitoring system using an ESP8266 based device. It continuously tracks heart rate, motion, and GPS location, sending alerts via a Node.js and MongoDB backend. The Flutter app provides live monitoring and emergency notification, ensuring timely intervention.
Alright, let's dive into how the system actually works. This device is packed with sensors that work together to ensure real-time health monitoring and safety for seniors. It detects sudden fall and irregular movements, helps in accurate fall detection, reducing false alarms, and ensuring timely alert for senior safety. We have the Node MCU. This microcontroller processor all the sensor data and send it to the storage so caregivers can monitor everything from their phones. Now, what if the senior need urgent help? Where the Neo 6M GPS module comes in. It tracks the real-time location, make it easier for caregivers to respond quickly. And the health monitoring, we have got the max 3102 sensor. This continuously track heart rate and oxygen levels. Super important for detecting abnormalities early.
The unsung heroes of circuit building. Those tiny wire shelf has to connect different components without any soldering. Right. There are three types: male to male, female to female, and a male to female. Each designed for different kind of connections. Now, what powers our entire system? A lithium polymer 3.7 volt battery. This compacted powerful battery ensures the device runs for extended hours without frequent recharging. And the best part, it's lightweight and rechargeable, making it perfect for wearable devices. But what if there's an emergency? That's where the SOS button comes in. With a single press, it sends an instant alert to caregivers. This quick response system ensures immediate help during distress situations. And finally, we have the breadboard, an essential tool for prototyping. It lets us test circuits, troubleshoot and modify connections without permanent soldering. It's like a testing ground before making a final design, saving time and preventing errors.
Our circuit consists of a node MCU connected to a heart rate sensor, an IMU module, and a GPS module. The push button acts as an emergency trigger. Power is supplied through a battery to ensure portability. The node MCU processes data and transmits alert when necessary.
Our ESP8266 based device monitors the heart rates, motion, and GPS. The IMU sensor detects fall based on acceleration changes, and GPS coordinates are captured using tiny GPS press. Data is formatted as JSON and sent to backend via HTTP when a fall or emergency is detected. The backend is built with Node.js, Express, and MongoDB. The backend stores sensor data and triggers SMS alerts via Twilio for emergencies or fall. It provides an API to fetch real-time data for Flutter app, ensuring continuous health monitoring. The data from the sensor will stored in the sensor data collections. Initially, it is empty. The Flutter app retrieves sensor data from the backend, maps it to a sensor data model, and displays it using Feature Builder. The UI updates in real time with the refresh indicator, showing heart rate status, GPS coordinates, and alert for emergencies. Let's run the backend. Our MongoDB is connected to the backend successfully. The data from the different sensors like heart rate, latitude, longitude are shown in the terminal. Let's check if our device measures the heart rate in real time. Yeah, it measures. Our MongoDB also shows the data in real time successfully.
Now, it's time to test our SOS button. When the SOS button is pressed, the message emergency is displayed in the terminal and it is sent to the caretaker's phone immediately. Now, let's check the fall detection. When we drop the IMU sensor, it immediately detects the fall and the message fall is detected is displayed in the terminal and sent to the caretaker's phone instantly. For our testing purposes, we have adjusted the IMU sensor sensitivity to detect even shorter falls.
It's time to see the data through our Caretaker app. For this, we need to build our app. It may take a while. Finally, our Caretaker app fetches the data from our database through an API and display it in a visually appealing way. And this is the data our app fetched. Let's see what happened in our app if we trigger the SOS button.
Our app alerts the user via the continuous notification to indicate that there is an emergency.
This system addresses the critical issue of unattended health emergencies, especially for elderly individuals. By enabling real-time monitoring, automatic fall detection, and instant alerts, it ensures faster response and improved safety. Future enhancements include AI-driven predictive analytics, cloud integration, and expanded sensor support for more accurate health tracking.